everyone, and welcome to what is undeniably, unquestionably, and unapologetically your favorite YouTube series. It's our favorite YouTube series too. Is that a coincidence? I don't think so. Maybe, but I don't think so. I've got Aaron and Lloyd and Anthony with me as always, the really bad security crew. And you know the purpose of this because you have watched the previous 28 episodes, right? Hopefully, if not, go watch them. But after you're done watching this one, this is episode 29. What Not Another Demo is where we have a real conversation with a security vendor. We get away from PowerPoint slides, we get away from marketing jargon, and we get away from acronyms. So if anyone, ourselves included, uses an acronym, it's the responsibility of someone else in the episode to ask them what that means. And that sometimes gets to be quite fun. But we do know why there are acronyms. So if you just explain it once, after that, then we can go back to using the acronym. This week, we are super excited. I think we're going to be tackling a bit of a new space here. So we've got Sean Boulter from Salt Security. And oh, Anthony, there's so many dad jokes that I can use with Salt. But I'll try to not, but something will happen.
Thank you for holding back on yourself.
Just for you. So Sean, welcome to our show. And I think I'm going to change the first question a little bit this week, in that I'm not sure that, because we're going to be talking about API security, and I'm not 100% sure that a lot of our audience, myself included, are super familiar with API security, the space, maybe how it developed. So if you could introduce yourself and then introduce this space to us and our audience, and then introduce Salt Security after that to our audience, and we'll go from there. So with that, the floor is yours.
Sure. Well, first of all, thank you for having me. I'm glad to be here. My name is Sean Boulter. I am an SE with Salt Security, been with the company almost 2 years. I was SE number 3, so that makes me an old timer because we're going fast. And you've already identified our first acronym. You mentioned API security. So
I didn't know it, so I was
honest.
waiting for you to explain it. Yeah.
Exactly, by design. So API, application program and interface, is what API means. And yeah, so in terms of API security, where it came from, if you want me to go ahead and answer that, I will. So the idea here is that we probably have known about APIs for a long time. They've been around for a long time. But what you may not know is that this is how modern apps are designed. You've heard of microservices, probably know a lot about them, but the microservices talk to each other with APIs. My mobile app on my mobile phone, when I log into my bank or Facebook or whatever, is making API calls to the application. So when you hear about data breaches and things that are leaked and whatnot, probably it was an API that leaked that behind the scenes. It's the thing that's transporting the communications back and forth between the user and the application itself. So hopefully that gives you a tiny little bit of context for what we're talking about today.
Yeah, it does. So let's switch over to talking about Salt Security. I'm hearing more and more about you guys all the time. So obviously you're making some noise in the industry. So I guess let me do the follow-up with what is normally my first question, and that is, hey, we all have way too many meetings on our calendars already. Why would someone want to take an extra meeting with Salt Security?
Yeah, a couple things. People that do take that hour with us kind of fall into two camps. One is I'm just starting to learn about APIs camp. I'm not quite sure why my existing tools aren't good enough. I've been hearing about Salt, or maybe one of our competitors. Salt was a first mover in the space, and it was kind of tough being the only person saying, hey, you have a problem. It's like, well, if you're the only person saying it, do I really have a problem? But now we have a couple of competitors, so that's getting easier. So that's one camp of people getting educated. The other camp is people who are under attack. Like we've done surveys and things like that, and the people that are responding are saying they see more than 100, like a third of them see more than 100 API attacks in the average month. And so when I start to say, this is how API attacks are different, they're like, save it, I see it all the time, so no need to educate. We're already on the same page. Let's move forward with how do you solve those types of problems. So that's generally why is either they're being attacked or they want to get educated.
Yeah, so let's jump right into it then. What is an API attack and what does it look like? And why do we need to protect APIs?
Yeah, great question. That's kind of the crux of it, that we have to be on the same page before we can talk about a solution. So API attacks are different than normal attacks. Gartner uses the word abuse. I like the word trick. Essentially, at the end of the day, you're using normal application traffic to try and trick the application. You're trying to find a bug to elevate your permissions or exfiltrate everyone else's data, those kinds of things. So in other words, if you're familiar with antivirus or WAFs, they're looking for a signature. They're looking for that known bad thing. They crack open the packet, they look for the known bad. If they see it, they stop it. If there's no known bad, they let it flow. So the situation is, what if there's no known bad, but this is part of someone looking for a bug in the app so that they can exfiltrate data? How do you solve for that? From a runtime security thing, that's probably the biggest question out there with how APIs are attacked and why they're different.
So with self-security, how do you guys solve that problem? Where you sit in that process?
Yeah, so that's one of the problems, is runtime security, and the way we've solved it is big data. So if I'm looking for abnormal, then I need to know what normal looks like. And the only way I can learn what normal looks like is to leverage big data, like cloud scale big data, in order to see if I can see all of the traffic. Then I can learn how normal users normally interact with this. What's normally in the fields? What fields normally match? How do they normally sequence through the application when they're going there? So then it becomes very easy to identify not normal. So think of this as like a bouncer in a bar, right? The guy, you've already presented your driver's license and you get into the bar, so you're fine, you're in the bar, but you start behaving abnormally. Well, maybe you're just a weird guy, right? Fine. But maybe you behave in a weird guy that is a bit threatening to other people. The bouncer is the one that says, normal people act a certain way when they're drunk, but this guy is threatening when he's drunk. He's dangerous. So let's just bounce him out of the bar. And that's roughly the concept that we're going for, is not only identifying what's not normal, but what is nefarious about the not normal.
All right. So you guys alerting and remediation, or are you simply letting the analysts or the SOC team or whoever know that this is happening?
Right. So we can block, we can stop. And so you have to think about how API attacks progress. API attacks progress through a lot of different trial and error, because I can't know ahead of time where your bugs are going to be in your APIs. If I was going to go after Apache or IIS or something like that, I would go see if I could figure out what kind of thing it is, and then look up a vulnerability and then just hit it with that kind of pattern to see if I can exploit it. I can't do that in this case. I know nothing about the API, so there's a lot of trial and error. And it's that trial and error that really gives them away. So what's all we'll do is bundle up all of these trial and errors together and label them as an attacker. So rather than trying to stop a bad signature, we're trying to stop a bad guy, right? Big data gives you the ability to bundle it all together, correlate it all together, and say, okay, this guy's been changing his IP address, but he's logged in as the same user all the time. So here's the bad user. We can either alert on it and say FYI, or we can actually take action and stop. Let's say that's a CRUD stuff. We don't really have time for a human to take a look and say whether they agree or not. Let's block this CRUD stuff attempt.
So that you hit on something that I was going to follow up on, is if the attacker is changing their user agent or their IP, but you guys are still seeing this happen, how do you go about blocking that if what you would block or what you're tracking is changing?
Right. So so that is something that's very key, is like, what can we correlate this on, right? So IP address is going to change. Maybe there's headers that are changing. But if you're talking about a user that is logged in and encrypted, so he's past the front door, he's got to have more than one credential to kind of to get by, right? So if he has the one credential and he's rotating IP addresses and headers and all of that thing, then the credential is the thing that ties them all together. But you know, he could have multiple credentials, right? So then it becomes more difficult to track them as they're continuing to use different credentials, different IP addresses. Eventually, they're going to be doing something that a single step that has enough bad stuff in it that we say, okay, this on its own, regardless of whatever else they've done, is enough to warrant a block. So we'll go ahead and send that block message. So first of all, we're not in line, right? We're out of band. We're getting a copy of the data, which gives us plenty of time for, you know, 99 point whatever % of the attacks out there. We see that reconnaissance that's going on, and we block that bad attacker. Right. So, but we're talking about runtime security. There's a couple of other components that you need to cover with API security. So I'll just kind of, let's make sure and we hit those when you're.
Yeah, don't worry. I got you covered on those, being a former web developer. All right. So You're going to get a softball question and you're going to get a hard one. Mine will be a little harder than Anthony's, even, since that's my world. Your softball question is, you know, API secure. What's the difference between your product and what you could get in a web application firewall?
Okay. Yeah, that is definitely more the softball side of things. So the web application firewall, or some people are calling them WAPs now because they're trying to me, it's more of a marketing term, of saying, hey, I can cover APIs as well. No matter what the label is, at the end of the day, if all you're doing is looking for known patterns, known signatures, that's great. You need that. Most of my customers have that, but you're going to miss the business logic based attacks, what I call a tricking, what Gartner calls abuse. Because if I'm not going to use one of those signatures and that's all you're looking for, you're not going to stop me, right? Because I am going to, so let me give you an example. Coinbase, cryptocurrency exchange. In February, they had this new feature that says, hey, instead of selling your crypto back to dollars and then buying another type of crypto, you could sell crypto A to buy crypto B. Cool. So security researcher finds out that, you know what, I don't even have to own crypto A to sell it to buy crypto B. I can just buy crypto B straight up using someone else's or even a bogus account number. So he tweets this out. 45 minutes later, Coinbase is down for 4 hours while they fix it, and they pay the guy $250,000 in bug bounty, right? There's no pattern, there's no signature, there's nothing to look for except all of his trial and error that it took to finally find that he could do this, right? So WAP doesn't stop business logic based attacks.
Good. Okay. Good answer on that one. All right. A harder one. So you say, you know, you leverage big data, looked for behaviors, right? And this is actual real world use case tying to what Anthony talked about. What would you do if a situation where you have a public API or a publicly exposed API, right? That doesn't contain any critical data, but it's out there for necessity, right? There's new government regulations around transparency, right? Where we have to put this, information out there, and it's not going to have authentication, right? There's no authentication because it can be out there for anyone to consume. That's the whole point. But now you run into a situation to where you have a foreign country that's starting to consume this data at an alarming rate, enough to where you could potentially bring your application down, right? Because, it's legitimately asking for information. Obviously, the scenario for that one is the bad guys are looking to see what the data is, right? We're gonna ask for all the data we want. We're gonna hopefully see it's PHI because this is like a healthcare system or insurance company. Right. In that situation, it's valid traffic, but it's being used in a nefarious way that could obviously potentially, not purposely DDoS, right? They're consuming information so fast that they're crashing the web application. So
Right.
what would you do in that situation?
Yeah, you have to look in the details, but essentially there's a couple of things that come into play here that I would say, okay, well, this could help and that could help. So one of the things that helps is we learn the normal rate per user for that endpoint. So you're calling www.something / something dash something dash something and get, it's a get request. I want to get this data. So we've learned that most users consume that endpoint at a certain rate. It's a dynamic thing that we're always learning. And so now we're seeing that, hey, this user is consuming it at a rate that's significantly higher than most other users. So we can either take an action or just alert, right? We can alert you and say, hey, this is happening. You go do your research, you find out that, okay, yeah, that's from that's nefarious or whatever, and you want to block it, or we could block it for you. So I don't know if that is kind of where you were going with that, but that's
yeah, that would solve the problem.
Rate,
so
that
it's not often I say this, but good answer.
Right. Probably if it's a nation state actor, they're going to be quite
yeah, this particular instance, obviously I can't get into details because I like my job. This particular instance, they think they were just snooping, and then they saw they could get more and more and more and more and more information. They didn't get what they were looking for, but that didn't make the problem any less severe, right? Because if you're consuming it so much, you take it down. It's a DDoS, even though that wasn't the intended, the intention of the attacker.
We're also looking at response codes, and we might send you an alert and we're saying, hey, we're seeing a lot of 504s. We don't normally see these 401s from here. This is we don't normally see this much data go back to a single IP address, this much PHI. So there's that kind of a baselining as well. So it's a per user per endpoint rate. That is difficult in other solutions. It's also the response. So you're not even, responses. So WAFs aren't even looking at responses. Like if you started leaking a token, like Facebook did famously in 2018, you wouldn't know, right? And this brings up PHI. You mentioned PHI, PII, sensitive data, all of that. So one of the thing we've been talking right now is runtime security. For us, that's the quickest time to value, like for most people, as opposed to, oh, why don't you just make your code more secure? Okay, I'll do that by
that
never,
wouldn't have helped
right?
in this situation, right?
This
is, they could, you can't really code it any differently because it's a publicly available, publicly exposed PHI. So in that case, the developers, they didn't do anything wrong. So it wasn't a secure code issue, so to speak.
Right. It does bring up two other areas that you need to cover in terms of API security. So we've been talking about runtime. That's the quickest time to value, lots of value there. There's also visibility. What is my threat landscape? What am I trying to protect, right? So visibility into knowing what APIs are out there, which is good, and even better is what sensitive data are they exposing, right? So you may be okay with what you think they're exposing, but what are they really exposing? And with CI/CD processes that we all have, it could be that you were aware of the sensitive data that was being exposed a week ago, but guess what? Something changed. And now, like in the Facebook example, there's a token that's being leaked, and it's just waiting for a smart guy to realize, hey, that token is not for my account. It's for Aaron's account. I wonder what I can leverage this token to do on Aaron's account, right? So it's knowing where is all my sensitive data being exposed, and should I be exposing that? Is it being exposed in a way that is a mistake? Like Peloton is a good example. I don't know if you remember this from a year and a half ago, I guess. It turns out that if I look in my browser and I see the API calls and I say, well, what if I uncheck the box about authentication? oh, I can still get Lloyd's personal information that he marked private in Peloton, right? And I can tell Peloton about it. And what they decided to do is, let's make sure that we enforce authentication, but they didn't enforce authorization. So now I could authenticate, I'm me, they know I'm me, but I'm still asking for Lloyd's information and getting it back. So, you know, what can we do to proactively tell the dev teams, hey, yeah, this is an issue, or you're carrying sensitive data in the URL, right? So just
And that
kind
would
of
be an advantage over a WAF, right? And we said what it was, Lloyd. Web Application Firewall, WAF. No, I mean, because you bring up a good point, because that would be one advantage over a WAF. So just for the listeners that aren't really familiar with WAFs, WAFs can give you the ability to protect a known bad thing, right? Like in Sean's point to CI/CD pipeline, you're up against it. You maybe even have a government deadline, or you know what have you. We're about to go live with X product. In the course of scanning your code, you may find a vulnerability, right? But that vulnerability may take X amount of time to fix, but you need to go live, right? So that's the power of a web application firewall, right? You can put protections in place, so you're allowing that vulnerability to go live, but you have the compensated controls around it. Whereas this way, you're kind of doing reverse, right? You're watching the behavior, and then if you're seeing additional data being exposed through that normal process, then you can go back and say, you know, did you intend to do this? Or, you know, because what is Netflix? I want to say my DevOps people tell me all the time, like they're pushing, you know, so many, you know, 30 changes an hour. I can't even remember what it is, but it's like stupidly unheard of number. And to your point, you can't queue, you know, you have QA processes, but even if you have a DevSecOps pipeline, stuff is going to get through, right? There's new vulnerabilities all the time.
Yeah. And you don't want security to be slowing down the business, to say, oh, hold on, wait. Right. So that's kind of the value of the runtime. Get the runtime up and running now, and you're not slowing it down later. But also knowing, where is my sensitive data? Do I need to expose a social security number back to the user? Right. Because if that's breached, if the attacker finds that bug, this is the data that's going to go back to them. Should they? Do we need that? I mean, why don't we just
kind of like that Nebraska government website where the governor tried to blame it, say the journalist was a hacker, but that would be a perfect example, right? Are you supposed to be able to see in your response all of this, you know, social security information?
Yeah. So yeah, knowing where are all my APIs, because if I can't protect what I can't see, and where's all my sensitive data being exposed by them, the same thing.
Sean, one of the things that we see sometimes is, you know, a $20,000, $50,000 problem being solved by a $500,000 solution. And so maybe for the folks that are out there that are not, you know, maybe don't know what their level of risk is in their environment, can you talk a little bit about like how big of a problem this is, what the potential you know, costs would be of having, you know, these sorts of vulnerabilities?
Yeah, sure. I mean, I think Facebook was fined 1.6, 1.8 billion in GDPR fines for their issues. I don't know how people quantify, you know, kind of the marketing side of the, you know, you look bad
loss
kind of thing.
Yeah.
What's that?
I think the reputational loss is something that,
yeah,
like you said, is kind of unquantifiable, but depending on the service your company provides can be astronomical. Right.
I mean,
look at when the Peloton stock, you know, sank to whatever, just because of the poorly tasted commercial, let alone their, you know, the technical issues.
Are insurance companies like yours? So to Sean's point, like, is that stuff that's being accounted for now in cyber insurance? Because I know, well, we're going to plug Acrisure for a minute. Acrisure is dipping into that space. Do they have brand damage clauses now?
If you're asking me, I honestly don't
No,
know.
I'm asking
No, he's
Anthony.
asking
Anthony,
me.
that's not secret information.
Yeah,
If
no.
they have it, you're not going to get fired if you say
No,
they
no,
have it.
I'm aware. I'm trying to think of the answer. I haven't seen one of those policies recently, so I couldn't
Okay.
tell you.
You
But
can get back to us on that one. No,
I
because
assume
you
it's
brought up a
probably
good
baked in.
point.
Yeah.
There, that
You're supposed to ask the
it's-
hard questions to the guests.
Yeah, Aaron, come on,
Do your own.
man.
I'm good with it.
So I guess, like, because I think you mentioned, like, not knowing what your APIs are. So is part of the process of working with Salt or implementing Salt being able to go out and see how many different APIs are running in your environment? I mean, maybe there's older applications that people are unaware of and things like that. Can you talk a little bit about that?
Yeah, sure. So it's a little bit of a chicken and egg, and here's how we get around that, what we mean by discovery. So the chicken and egg is, you don't know, you as, let's say you, meaning the security person, right? Whoever's in charge of application security or cyber, you may not know of all the APIs that are out there. And sort of a discovery process. But if you can put, Salt uses policies and like API gateways, policies, and load balancers that go in at more of a global level. And that way, when someone adds a new API, you automatically get that visibility inside the Salt dashboard. And so there may be a ton of APIs that are on that API gateway that obviously whoever manages that device knows about, so it's not new information to them. But it might be new information to the cyber folks, the AppSec folks, of holy cow, you guys have a ton of APIs on there. So that's part of what we mean by discovery. The other part is down to the parameter level, or some people call them fields. So we discover down to the parameter level of every endpoint, including things like GraphQL, which is kind of an up and coming way to write API code. So we know which parameters in those APIs are carrying sensitive data, right? So we learn that, hey, there's always letters here, there's always numbers here. Oh, this one always has email address. This one always has a social security number, things like that. So we do the automatic classification to tell you where that is. So that's what we mean by discovery in terms of knowing where my APIs are and knowing where my sensitive data is.
So I'm with Matt. This isn't my subject matter, that I know very well yet. So yeah, but I'm curious, maybe this has already been answered, but with API keys, I hear people talk a lot about different keys. So do you guys do anything with the keys? Like, how do you manage those?
Yeah, so we don't manage anything. We don't do anything that an API gateway would do. We don't do much that a WAF would do. We like to say that we cover the big gap that those things leave behind in terms of API security. But for the keys, we leverage them. Like if you're constantly logging in with your same credentials, but you're rotating your IP addresses because you figured out that you can do that inside the cloud and keep standing up different instances and whatever, then we say, well, this guy's, changing his IP address, but he's got this one account that he keeps leveraging, because we can see the key. We can see the token, we can see inside the JOT, it's all decrypted when it comes to us. So
do you have a tap
that
to get that information? Because you talked about a couple different spots, talked about having it at the load balancer and other places. Do you effectively just have a tap, so to speak?
Yeah,
I could put a tap on my load balancer. I could put a tap on the web application server. And then that makes sense, right? Because that would help with your correlation, because you want to, in theory, the data, that the API traffic should look the same throughout the funnel, right? And then if you see some sort of behavior, you could then do an alert on it, right?
Yeah, exactly. So it's often called a tap or a mirror. Whatever you like. If you think about what the FBI, CIA, NSA do when they listen into your phone lines, they probably call it a tap. We're doing the same thing. So it's an out of band, asynchronous listen in on the traffic, so that and the cool thing is we're listening in on a spot where it's already decrypted. So I don't have to mess with keys at all.
Right.
The solution already handles the keys and certs for me, and I don't need to decrypt.
Cool.
But yeah, it's a listen in via tap type technology. We could even consume packets if the packets are decrypted, right? So that's another idea.
Lloyd,
we're
you
getting down.
usually ask questions about pre-sales and stuff. What, now that you're on the Optiv side, what kind of questions do you have regards to that?
Oh, yeah. So yeah, talk to us a little bit about that pre-sales experience. You know, what can you guys do? You know, come in, do proof of value, proof of concept. What does that look like? What kind of support do you give? Kind of walk us through the process there.
So I'll walk through that. We used to call them a proof of value, a POV. And then we started calling it an application security assessment, right? So that's sort of a lighter weight proof of value that just says, okay, let's work to find a spot in your environment that has traffic, that has an application that someone cares about, and let's tap it and send that over to Salt, right? So there is an on-prem component that deals with data privacy. So you're not sending actual social security numbers to Salt, but a lot of times those environments have mock data anyway, so we don't care. So we're going to send it directly to Salt's cloud. So within minutes, usually, then we start seeing that data show up in Salt dashboard. So you log in, you see, okay, here are my APIs. Here's the one that we tapped. And oh gosh, it's got 50 different endpoints. If you don't know what an endpoint is, it's just a different, when you look at your URL in your browser, each time that URL changes in API terms, that's called an endpoint. And these endpoints are exposing, lots of different sensitive data. The parameters get classified. And so then, we can show the customer, hey, here's the API we tapped. Or if we did it at a global level, here's all the APIs that started showing up because we're at a global level on a gateway or something like that. So that's kind of step one, is discovery. Step two is what we call prevention or runtime security. We'll actually, if we're in prod or if it's actually exposed to the internet, we're likely to see live attackers right away. If not, we can do some attack simulation. I would be remiss if I didn't mention a new top 10 list from OWASP. It's about 2 years old. Aaron, you're probably already familiar with it. OWASP API top 10. It's another recognition that attacking APIs are different.
It was due for an update. I'm not gonna lie.
Right. Yeah.
Much needed update.
For sure. So we will launch simulated attacks to show that, hey, Salt learned your APIs well enough to know that that this is never done, and so then this thing gets classified as an OWASP API 1 or a 2 or a 3 or a 5 or whatever it is. So there's an attack sim phase. We also have a bunch of security researchers in Tel Aviv, where the company was launched from, that will do actual, we call security research, and say, hey, here's this actual bug in your code, and here's how I could have leveraged it to exfiltrate everyone's records, right? And here it is in the Salt dashboard. Here's me and my IP addresses and my accounts and things like that. And I didn't push the final button because I didn't, want to exfiltrate that. But so those are kind of the steps. You got the discovery piece, then you got the runtime prevention piece. And there's a third piece where we'll say, oh, you know what? We've seen some mistakes in the code. We've seen some these things that the attackers have done. We want to close the loop with the developers and open tickets in Jira or something like that to say, you know what, if you had bothered to do field validation, this wouldn't have happened.
Well, we like to word it a little bit better than that. One way to piss off your devs is you can trust me, I've learned to politely call them out, almost like you chide them like better, but I don't know that I would be that blunt in this Jira card.
Exactly. I'm just a little more salty than most. So
that was good. You
dad joke.
You say this product is worth its salt?
Ooh. Man, I am off my game today. That's supposed to be my job. Sean, another aspect, the flip side of the pre-sales process, of course, is the post-sales process. And another area that we have notoriously seen vendors fail is after the PO is signed and you no longer stop caring about them as a customer. So talk to us a little bit about what working with Salt is, not just to the PO signing, but beyond that.
Yeah, great question. That's a great point. We have a customer success team that reports to the product manager at this point, right? And that customer success team is bundled in with the price of the solution. So you won't see a line item that says pro services or onboarding or anything like that. You will just see a volume-based price. And these guys, they are tasked with onboarding you. So there's a guy that is kind of over that team. He's got some essentially project managers and some subject matter experts to figure out, okay, where are we going to get the data from? What's the best way to do it? And then let's plan this out. So we look at it as a partnership with it's easy for a pre-sales person to say all these wonderful things, but we look at it as a partnership. For a lot of our Fortune 100s, we actually have the CEO on the phone saying, this is a partnership. We will onboard you. We will build whatever it takes. If there's a new integration that needs to be done, that's on us to create. But it's the customer success team that's responsible for going and identifying what success looks like and then creating a plan to get there.
Yeah, I like that. I think that's important. And I am starting to see more organizations, move to that sort of a model, which I think is a good thing because, most of the time when I have seen a product get ripped out and replaced with something else, it's not a technology issue. It's a customer service and support issue. So good to know. That you guys
they stop giving a crap about their own code, right?
Until it's time for the next.
There's some companies that we won't name names, but yeah, they've forgotten the importance of the developers making their own software.
Yeah, for sure.
So guys, I learned some stuff today. I learned that it has taken Anthony about 2 weeks to start becoming proficient with dad jokes, which I think is pretty impressive. For him.
I've had a good mentor, so.
I can retire now and we'll leave them all to you, Anthony.
Yeah. I've had a good mentor for that, so I got you to thank, Matt.
I think we've also learned that API security probably is way more important for your organization than what you may think it is. And if you want to talk to someone about it, right? I also heard earlier, and I think one of the best things that Sean, I heard you say earlier was first conversation can just be about educating someone about what API security means. So I did really love that when you said that earlier, because I think, again, too often we see companies jumping or vendors jumping right into the sales process without really understanding, or the customer even understanding why they're there in the first place. So bravo for you on that answer. Very well done. And also, Salt Security going to be one of the Grand Slam sponsors at CloudCon this summer. So we're super excited to see them be a part of the big event and presenting on the big stage. And so July 25th and 26th, don't forget about that. Anyone watching this?
No pressure there, Sean, if you're going to be part of that.
Are you going to be the presenter, Sean? Have we figured that out yet?
I don't think we figured that out yet. I'm certainly open to it. We have a lot of folks that would be great at it. So
it is a
all
great.
I'm going to say is Grand Rapids is
Yep.
Beer City, USA. So there's that. If you make your way over here, yeah. All right. Hey, like, subscribe, share all the great YouTube stuff. Sean, thanks again. This was fantastic conversation, and we'll see you all next time.